I hope you're having a good weekend, starting a new week here, and we're down to about 2 weeks before the big eclipse. Let me turn my mic down. I think it's probably running a little bit hot. All right. We do have some thunderstorms in the area, none in this part of Texas. But let me switch over to our radar from College DuPage. And there it is. Some storms there in the Dallas-Fort Worth area. Mostly in the Fort Worth area, and we had a little bit of a supercell appearance earlier, and that's kind of gone away. You can see now we've got a outflowish structure. The main cell's back behind this outflow boundary right here. Now that is a little bit of a MCS there, and I wanted to discuss that a little bit. Let me go into the different kinds of scales, because when we talk about MCSs, mesoscale convective system, that's defined by the scale of the system, and we have a time scale and a space scale, or volume or size. So when we're talking about, let's see, like maybe a few hundred meters, that's going to be on the scale of thermals, like rising up and forming cumulus clouds, and we can see that that kind of falls along this slope here. So that thermal has a scale on the order of maybe several minutes to maybe about 15-20 minutes, and then we get up to tornado scales and then storm scale, which has a scale of kilometers and starting to get up into hours there. Now, MCSs, those are way up the scale. It's not defined simply by thunderstorm scale, but that's going to be way up here, almost towards, actually more like right here. So we're talking more of mesoscale, almost synoptic scale. And that's going to be probably on the lifespan of almost a day there. And there's a look at what the mesoscale convective system looks like, and you can think of that as looking east for a U.S. system. And this area here, this is all the updraft portion of the storm, and then back here we have the downdraft. And it's actually the downdraft that's most visible on radar. So this is going to have a lot of reflectivity right here. And then the part of the updraft where we have condensation of precipitation, that's also going to show up on radar there. The part of the updraft with the smaller particles here, this is not going to show up quite as well. So this is going to be kind of a, I guess you might say, a rain-free area, a weak echo area. So when we look at the forward part of the MCS, we're going to see very little precip, and then we get up to the upper part of the storm, and then we'll see some higher reflectivities just above that updraft base area. This is what the MCS system looks like. This is its relationship with the synoptic scale systems. So we have an upper level trough to the left, or to the west, and then we have the downstream ridge to the east. And typically these MCSs are ahead of cold fronts. They can also be along and north of warm fronts. But what's important is we have a large area of moist air advection feeding the MCS, and typically there's a low-level jet feeding the storm system. This is a tropical squall line, and it's embedded in the tropical easterlies, and this has a westward motion, and you can see that the MCS has a little bit of a bow echo structure right there. And there's this large area of trailing stratiform rain, and that's kind of important. If you're familiar with MCSs here in the U.S., there tends to be a lot of lightning trailing the storm by 1 to 2 hours often, and there will be a kind of a continuous steady rain. And we can see a cross-section of that right here. There's the trailing stratiform rain, And there's this bright band here where the precip above that level gets into sub-freezing air, and we tend to have more ice crystals. So those are falling as snow, and as they start melting, the reflectivity levels come way up, because ice is a very good reflector of radar energy. So it forms this bright band, and typically that's about 5,000 to 10,000 feet above the ground. It can be a lot lower during the winter time. So there's another look at an MCS, and let me grab my notes here. Sorry, I got about like 15,000 windows open here. Okay. So there's a look at a conceptual MCS right there. That can be defined by size, greater than 100 kilometers is one definition, by time, greater than 3 hours. But the important thing is that the MCS is longer lived than the convective elements that form it, like these updrafts. And the storm too. They can also be identified by the anvil size, and Robert Maddox, back in 1980, he did a very important paper that identified MCSs, and he was looking at the total area as seen on enhanced infrared imagery. And I think his definition was 30,000 square kilometers for 3 hours. And there's a look at some different types of MCSs. The trailing stratiform is the most common. But sometimes we can have a leading stratiform structure. This is a lot more rare. And this is where you have a slow buildup of showers and rain, and then the convective elements finally arrive. And that requires a different shear structure in the atmosphere to support those. Now this is an interesting MCS diagram showing the typical locations. At the very top in May, there's a tendency for those to form in West Texas and Southwest Kansas, and then those will move in Arkansas and Louisiana later during the evening. And they tend to shift northward with the instability. So by June, a lot of them are forming in the high plains, and then they end up in the Mississippi River region, the upper Mississippi area, by late nighttime, early morning. And these storms are strongly diurnal because they're supported by the low-level jet. The low-level jet, of course, is nocturnal. It reaches its peak about 2 to 3 in the morning. And that's kind of the mature phase of the MCS, and by that time, it'll usually be in Missouri, Iowa, with a low-level jet feeding the MCS like that. And then they tend to shut down towards dawn as they move into Illinois and Indiana. And then by July, a lot of them are found in the northern plains right there. And then they end up in the Great Lakes area by the next morning. And there's a quick look at a diagram of a tropical MCS. And this is the area to the west where the storm is moving toward. And we have the main updraft area right there. And you can see how the MCS is comprised of multiple towers. And some of those towers are overlying the precip area, and that's how we get lightning way back here. It's a combination of these updrafts and all the ice crystals falling out of these convective towers. So we'll have these long positive strikes reaching the ground, and you've probably heard those. Those are like bombs going off, even a few miles away. They're very distinctive. This is a diagram of where MCSs are most common. This is a quantitative study there. And you can see that they're most common in Kansas and Oklahoma. in western Missouri. And then here's one more look at MCS. So what do we see here? Some of you probably recognize the bow echo structure. See how that kind of bows out, but there's one feature that's also associated with that, and that's the rear inflow notch area, the rear inflow notch, and that's located right there. And that's a good indicator of strong winds embedded in this bow echo. So what we're looking at there is very strong reflectivity gradients back here and very high velocities. And this is essentially the strong winds reaching the ground way back here. And there's a very strong correlation with the rear inflow jet, which is what this is. The strength of that rear inflow jet, strong winds in the mid-levels, and the arrival of very strong winds at the ground. And this is controlled largely by vorticity aloft, like horizontal vorticity tubes, if you want to consider it like that. When we have very strong cold pools, you have very strong descent of the downdraft, and you'll have the strong rotation, and that tends to augment. These little curls here, those will augment the rear inflow jet and bring that right into the back of the storm, almost like rollers. Very strong updraft also. We get a sense of rotation like this. So it's almost pretty much like a little roller system, basically just piping that rear inflow jet into the back of the storm there. And right to the ground where we get strong downburst winds there, and it helps produce the bow echoes. So there's a quick primer there on MCSs, and you could probably read a lot more about that on the internet there. So we got that that cold front coming southward. North winds coming out of Oklahoma and Kansas this evening, and the leading edge probably running something like that right there. And then the warm front somewhere up in northern Arkansas there. So we can take a look at our theta E field to find where the better moisture is. The better moisture and temperature, the best ingredients for a strong updraft. And it's a very noisy field, so we have to kind of look at the big picture and kind of filter out this noise. And what we come up with is kind of a tongue of high theta E right there. And the axis of that is located from about south of Houston into the Dallas area, so just along and west of I-45. So that's the best support there for this MCS storm. So there's going to be a tendency for that to move possibly to the east or to the southeast. And then we'll lose that storm after we lose the heating and after it moves east of that moisture axis. Okay, and we've got a few storms also up in the Midwest. Let's see if I can bring that up. And that's located in northern Tennessee and in Kentucky. Looks like around the Paducah to Louisville area. I don't think that came up. Okay, there we go. So this definitely has the look of a warm frontal system, because if you look up to the north, there's hardly any convective elements. It's very stratiform. And then the stronger elements are down to the south. So that's going to be along some sort of warm front. And then we can look at the moisture field. And we see that the better moisture pretty much located right there in Mississippi and Alabama. Okay, the 250 millibar chart, we'll check that out very quickly. We usually look at the Canadian chart because it has a very clean appearance, but it also has a vast amount of data. You can see all the ACARS data. This is from airplanes. And you can see that this is along the track going out to the Hawaiian Islands. So those planes flying to Hawaii, they're actually pretty important in gathering weather data for systems approaching the west coast. So we get a better picture how they're structured. And what we see here is a little bit of a medium wave ridge across the southwest, a cold core low over the Northern California area. And then we've got a rather large system across the Great Lakes and Ontario and Quebec. And the stronger baroclinicity located over the southern Great Lakes right there, northern Ohio. So that's supporting a frontal system out to the east. So we're going to expect to find that in the northeastern U.S. and Canadian Maritimes. And this is showing the pretty good polar front jet there at 200 millibars. This is up at 40,000 feet. And we can see one segment coming on shore there. That could be a piece of the subtropical jet right there. And indeed, if we go to 500 millibars, look at how that velocity goes away. We only have 15 knots at 500 millibars, which is 18,000 feet. In fact, let me show you the top right there. Okay, so you see 200 millibars, good strong 60 to 70 knot jet, and then that goes away at 500 millibars. But it looks much different in the Great Lakes, 100 knots, and then at 500 millibars, we still retain 40 knots of flow right there, and even 50 in Vermont and upstate New York. So this is a polar front jet, and this is a subtropical jet. And this is the theta E, or I'm sorry, not the theta E. This is the theta, which is potential temperature. This gives us an idea of where the fronts are. So probably a front right there, supporting that Tennessee system. And then it looks like that front in Texas is separate. It's got more of an appearance like that right there. Okay, then we'll take a look at an animation here, and I'll run this back about 15 frames. This may impact the stream just a little bit, but it's just temporary. Well, we got that really zoomed in, but there's the overshooting tops there in the Altus area, Frederick and Altus, Oklahoma. And we can see the other MCS there in the Fort Worth area. And there's one overshoot. That's going to be the dominant storm right there. And that's kind of drifting southward there. So we have a lot of activity here at this time in the southern plains. And then up in the central plains, you can see more of a stratiform appearance. So a little bit of cool, mild air, dry air coming south. In fact, it looks like it barely moves there, very little movement in the low cloud field. It almost looks like a snow field there. All right, we'll just go ahead and head right into the thickness, and after that we'll take a look at GR level 2. There's the thickness chart, and this is suggesting one little system there in Tennessee, and then the other one there in Texas. And looks like we have a new one coming out of the Northwest Territories. There it is right there. So it looks like we have probably another outbreak of cool air on its way to the southeast. For our soundings, we'll look at Fort Worth. And what we see here is some pretty decent moisture in the low levels. Fairly weak flow all the way up the column, very little bulk shear. So there's been a little bit of a change today, somehow in the weather pattern. If we take a high of 92 and then mix this column right here, there's our lifted parcel. We definitely have instability, but there's a tremendous amount of capping. So something has happened to erode this. And I'm pretty sure it's not just the frontal lift. So there's been some sort of change. It could be advection, or it could be potential instability being released and cooling the mid-levels. So one way we can tell is look at the vorticity chart. And this shows the patterns today. I think we'll have to go all the way back to 12Z to see what's going on. Okay, so there's the 12Z patterns. Looks like maybe a little bit of a shortwave moving through Oklahoma. The lift would be focused out ahead of that, so maybe there has been some upper level dynamics working on the atmosphere. And then finally, later in the afternoon, now we start getting a little bit of ridging starting to build in there. Okay, so that's probably one source, and now another way we can change the sounding is by advecting in a whole lot more moisture or providing a lot more heating. So one way we can see what's going on is to pull up the evening sounding. And there it is. It looks like we indeed have had some very strong mid-level cooling. So I guess that shortwave was very strong there. Really changed the mid-levels there. So now we lift our parcels. We'll do like 92, 93 Fahrenheit. Now we have very little capping and quite a bit of instability there in the mid-levels. Very steep lapse rates from about 10 up to 17,000. Okay, we wanted to take a look at the radar. So I'm going to load up the Fort Worth radar. Okay, GR level 2, non-response. There it goes. I guess it was loading up the warnings there. Okay, we're downloading the radar. So let me take a look at chat. And I can see we have Andrew and Carl. And Ryan is here from Florida. David Holcomb. Storms in the forecast there in South Florida where Ryan is. We have Sue M there in Indiana. David Moore, storms passing to the west of Fort Worth. Burl H and Eddie W and Funwood Tech. A little discussion there about eclipse glasses at Walmart. We have Alexi and Justin and Carl. Michael Burrell. Justin says, really like it when you teach us theory and use graphics. Yeah, I'll try to add in these little primers when I can here. Are there any radar products that precisely define storm margins? I'm not too sure. You'll probably have to, I guess, define that question just a little bit better. David Holcomb says spectrum width can help a little bit. Ryan Toomey's after midnight. NHC expected to forecast tropical storm warnings for Belize. Yeah, we do have that wave off to the south. In fact, I can probably bring that up on the polar orbiter data. Okay, system running a little bit slow, but yeah, that's a huge change right there. Very strong system southwest of Jamaica. And last we checked, that was heading west-northwest, so that's going to graze the coast of Honduras there. And then Belize located right here. And then we'll check out the NHC weather and see what they're expecting on that. So Tropical Depression 7. Potential Cyclone 7. And they've got the track of that running right through the area south of Cancun. So that'll make landfall there in Mexico, and I guess we won't see more of that. We won't see any of that here in Texas. Seems like we just have not seen much hurricane activity in Texas. Usually these systems are either coming on shore here in Mexico or they're heading up to Florida. It's always been one or the other. Okay, Ryan saying YouTube is slow with the likes. David Moore checking out that storm near Fort Worth. David Holcomb just got notification the channel is live 15 minutes late. That's pretty crazy because I scheduled the webcast at 5 in the morning, so there should have been plenty of time for YouTube to send out that notification. But if you have any ideas what might be causing the delay, let me know. There's one setting in here I can show you where I set the notifications. That's on this advanced page. And they've got this promotion. I don't know if this is related, but it says promote on my channel page 1 day before the scheduled time. So I don't know if that... I don't see anything else in here that does the notifications. So, like I said, if you have any ideas, feel free to let me know and I'll check it out. Derek Seymour, new name there. Welcome to the webcast, checking in from eastern North Carolina. Cape Hatteras, very well known for hurricane activity as we get into September and October. David Moore says the humidity went way up at 5 p.m., perhaps warm front. Yeah, that could be. I haven't looked at the surface map yet, but that is possible. We do know that the atmosphere really improved between 6 a.m. and 6 p.m. here. And Justin says, webcast idea, how to find the subtropical jet and what it means for North America. And that's probably a good idea, especially as we get into fall when that subtropical jet is active. All right, we'll head into the forecast and see what's happening. Maybe I should look at GR level 2. Yeah, you can definitely see that outflow boundary. And if we bring up spectrum width, that also shows up pretty well. And that spectrum width can be very helpful for finding the updraft or the outflow when it's extending into precip areas. Okay, storm relative velocity, I've got it. I think I've got that set to 0, or let me see here. Yeah. That's set to 0, so it's just showing ground relative velocity, but there's that strong outflow coming away from the radar. Since the stronger velocity is right there, I think we're probably looking at a south-southeast wind in that outflow. So probably heading sort of towards Hillsborough and west. So there's that motion there. Not much development along the leading edge at this time. Okay, let's indeed check out the forecast. I'm going to set this on Texas. Yeah, it looks like the 0Z model data has come in because we've got a 0Z run here. So this is all going to be fairly new. And so we're seeing the main thrust of this MCS going down I-35 towards Waco and Temple. Heading straight towards the better moisture. Coming in through Austin there around 1 or 2 in the morning. And coming through Hearn and Centerville about 3 in the morning also. And then that arrives down in Houston about 7 in the morning. Large stratiform area. This is that trailing stratiform area that we talked about earlier. So there's going to be a little bit of lightning in here, a few positive strikes, all the way from College Station up to Waco tonight. And then we have a little redevelopment tomorrow, again in North Texas. So this is a very classic northwest flow MCS. We tend to see that a lot in April and May, and again in August and September as we get into fall. Okay, then heading to the GFS model. There's tonight's pattern, and we know that there's a warm front right there around Memphis and another cold front here in Texas. And for tomorrow, we're going to see mostly things dominated by this high pressure area in the northern plains. This is a big high, 1022, 1024 millibars, pushing cold air southward. So by tomorrow afternoon, evening, we're going to have a front way to the south, probably in the San Antonio, Corpus Christi area. North winds in North Texas, dry air filtering southward. And then here's that other system in the East Coast. So that'll be coming up the Atlantic seaboard there. For Tuesday, things are pretty quiet. Things dominated by this high pressure area. So by Tuesday night, just a front to the south, a little bit of weak precip and across the southern U.S. And that's due to a little southerly flow getting established and a little bit of frontal lift as that 850 flow moves over the frontal surface there. Okay, then for Wednesday, a little bit of frontal redevelopment in the Panhandle. New system coming out of the Dakotas. And here's that system way down in Mexico, making landfall. See, there it is. You can see it off to the very bottom of the chart. So that'll be making landfall around Wednesday. And I don't know if we're going to have any of that moisture making its way up to Texas. These systems have a lot of precipitable water, but we would need some sort of southwest flow to advect it up into Texas. Okay, for Thursday, things are pretty quiet once again. A little bit of high pressure pushing this weak frontal system into the Midwest. And then Friday coming up, looks like that system will stall out in the Central Plains. Plenty of convection there for the eastern Colorado area. Probably nighttime convection over Kansas. Not much for Texas. And then for Saturday, that front finally starts seeking southward, shifting the precip down into the Panhandle in Oklahoma. And then for next Sunday, a week from now, high pressure gradually settling down on the Midwest. So just a very slow change through the weekend, and then we see that cyclogenesis up in western Canada starting to change the flow. So it looks like more rain in the southern plains for later next week, and then around midweek that'll be mostly focused on Colorado and the Central Plains. Okay, one last look at chat. David Moore tracking that storm through Fort Worth. Didn't get a drop there where he is, but the west side of Fort Worth got some. Carl Burkhoff finds it interesting how the thickness and sea level pressure paints out the frontal system so well. And that's definitely a very good tool, and we'll continue using that through the cold season. That'll be coming up in about 2 or 3 months here. Justin says, I don't think the notifications fire until you start online. So good question. Maybe I'll Google that and see what I can find. Okay, I think that's about all I got for this evening. I appreciate you watching the webcast, and hopefully we'll see you tomorrow. Take care.